Okay, in this video I'm going to show you how to use the jump software and the add-in that we installed, the distribution calculator, to work some binomial probabilities. So what I've done for you in learning modules in week 2 is I've put a PDF in there of an example using the binomial distribution. It's at the bottom here, as you can see. Above that, there was actually some review notes on the binomial. I say review notes because the binomial was a topic taught in Statistics 1. These other distributions we're working on, like the Poisson, negative binomial, and geometric, those were not in Stat 1 when you took it. So those are probably new to you. But this binomial example is an insurance example, so let's give it a look. It says an insurance company has 11 policyholders who are considered high risk. The probability that one of these clients file a claim in the next year is 0.25. All right, so first things first, remember the negative binomial and all of these distributions we're studying, they have these values that kind of define them and make them up, and they're called parameters. The binomial distribution has 2 parameters. The first one is the total number of trials, which in this case, as you can see, is 11, and we use the letter n for that. And then the second parameter that makes this distribution up is the probability of the event that we're talking about happening. A lot of people just say it's the probability of success. And here, that's, a person filing a claim, which is a little weird to call it a probability of a success, obviously, because, filing a claim is a bad thing. But sometimes when we're, a success could be a bad thing. It's just that we're looking for the event occurring, all right? So now think about it. If there's 11 people in this policy that we're looking at, how many of them are going to file a claim in the next policy period? Well, that's a random variable, obviously. I like to give a look at the what this thing has, looks like on paper. So if you're looking at 11 people, maybe none of them will file a claim in the next year. It's a possibility. Maybe one person could, and so on and so forth. I mean, all 11 of them, of course, could file a claim, which I think would be a little unlikely, but, it's an event that can happen here, so we're going to include it in our sample space. All right, so here's what our distribution looks like. Our x values, there's actually 12 of them. The 11 that we're thinking about, but plus we have to include the possibility that nobody does what we're talking about. All right, so let's look at letter A. It says, what is the probability that exactly 2? All right, so that probability statement, P, the probability that x is exactly the number 2. All right, so in our table, that is referring to this probability right here. So we're looking for this probability that goes alongside 2. Now remember, if we were to work all 12 of these probabilities out and add them up, that result would be 1, don't forget. All right, so now what? Well, you may have learned how to do this question on your TI calculator, and if you remember, you could do that if you'd like. What I'm going to do is I'm going to show you how to use the jump software to work it. So in jump, remember, we put a couple of add-ins in there. So you go to the add-ins menu, and it's in teaching modules, and there's this calculator called the distribution calculator. So I'm going to use this distribution calculator. All right, so as you can see, the distributions are up here. If I pull this pull-down menu down, you'll see there's a bunch of different distributions. The one we're working with is binomial, so I'm going to switch it. And you'll see the shape of the distribution in the picture changes. And when you look right under the binomial here, you see it says parameters. And obviously, those are the parameters that we were discussing before. Remember, the binomial has 2 parameters. And those parameters are the number of trials, which is n, in this case was 11, and P, the probability of success, which in this case is 0.25. All right, so I'm going to go back to jump, and I'm going to input that into jump. So the probability of success is 0.25, and then the total number of trials is 11. And you'll notice when I click out of these input cells, these input fields, you'll see the shape of the distribution changes. All right, and so every time you change these parameters, you'll notice the distribution shape change. All right, so notice right now the default when you get here, what's going on when you look at this calculation section. This first button is selected, which x is less than or equal to q. They're using q there as a generic variable to represent, what we're talking about. So notice they put, there's a 1 as a default in here, and being less than or equal to 1 is what this represents. And notice the bars for 0 and the bars for 1 are both shaded. So that's a combination of probabilities for 0 and 1 together. That probability is called an at most probability. We don't want that. What we want is just this bar for 2 to be shaded. Now, if you look down below, there is no option for, just equals to, which is a little frustrating, but you could kind of trick it, and I'll show you how. If I use this button right here, the third one, this is the in-between scenario. X is in between those two Q values. So if I go to value 2 and put a 2 there, and leave value 1 alone. So notice what I did. I put a 2 where value 2 is, and I left value 1 alone. What it does is it says, if you look at this statement here, shade between Q1 and Q2. So shade between 1 and 2. So what's going on, but notice it says don't include 1. So notice that the bar for 2 is the only thing shaded. So your probability is listed down here, 0.2581. So this is how you can kind of trick this thing into, giving you an exactly probability. So when you want an exactly probability, put the probability, the exact value you want in value 2, and put the value just before it in value 1, and then verify that you actually have the probability you're looking for, and you'll know that because the bar is shaded clearly. All right, so this value is 0.2581. So if I go back to my question here, this value right here, 0.2581. .2581. You notice sometimes I draw and it doesn't show up, or it shows up for a split second and then goes away. It's the wonderful bugs that live inside of Windows. There's no escaping them. All right, so let's give a look at letter B. And by the way, if you want, we could work all these probabilities if we'd like. Every one of these probabilities would be worked exactly the same way in this table. And if we want, we could work all 12 of them. That would just take us some time. All right, so let's look at letter B. Letter B says, what is the probability that no more than 3 will make a major claim? All right, no more than 3. All right, so the probability X is less than or equal to 3. That phrase, no more than 3, is the same thing as saying at most 3, which means less than or equal to 3. All right, so what I'm going to do is I'm just going to clean up my table a little bit. That's these probabilities right here, no more than 3. Now, if we want, we already have the answer for 2. We could get the answers to 0, 1, and 3 the same way we found the answer for 2. And once we have those 4 probabilities, we could just add them up. The beauty of the software is we don't have to do that, though. So there was a feature for that in Jump. So if I go back to Jump, notice that's this button right here. I want 0, 1, 2, and 3's probability. In other words, when I go back here, the probability X is less than or equal to 3 is equal to probability X is equal to 0, plus the probability X is equal to 1, plus the probability X is 2, plus the probability X is 3. So it's the sum of those 4 probabilities, which would be the equivalent in Jump of seeing the first 4 bars highlighted, and then we could pull that probability. So what I did was I selected the first option, X is less than or equal to Q. I'm going to go in the input value and change that out to a 3. Hit enter. And notice the value that I put 3 in there, it highlights those 4 bars. And as you can see, the probability is 0.7133. All right, so this value would be 0.7133. What's kind of neat about this is I didn't even know any of those probabilities right there, but we were able to work the sum of all those probabilities. That feature in JUMP actually is called the CDF, the Cumulative Distribution Function, and the TI Graphing Calculator in its distribution menu has a binomial CDF and PDF feature. This PDF feature, you may remember from Statistics 1, is the exactly scenario, and the CDF feature is the at most scenario. So you can look into how to work that if you'd like on the calculator as well. But this, the calculator isn't so visual. JUMP does a great job because of how visual it is with the graph. All right, so let's give a look at the next part. The probability that at least 5 of them will file a claim in the next year. All right, at least 5. All right, so let me clean this thing up again. At least 5 means 5 or more, right? The lowest it's going to be is 5. It wants all those probabilities. All right, so the probability x is greater than or equal to 5. So one way we could do it is we could, just like we did part A, we could work 5, 6, 7, 8, 9, 10, and 11's probability, and we could get those values. That would take a little bit of time, obviously. One really clever way would be to remember that all these probabilities sum to 1. We could work 4 and backward exactly the same way we did part B, where we worked 3 and backward. So if you think about it, this could be 1 minus the probability x is less than or equal to 4. And you'd be like, all right, well, why should I do it like that? Can I just work 5 and forward? Well, in JUMP, you kind of can. There's a forward calculator, as you can see. It's the second one, but it just has a greater than sign on it. So if you wanted to do greater than, you would have to say greater than 4, and then it would work 5 and forward. So there's a couple ways you could do this. You could work out 4 and backward and subtract from 1. That'll get you 5 and forward. Or this button right here, if you put 4 in there, which is weird because it's talking about being 5 and greater, right? But look at the calculator. That's the key. It says greater than that. If it said greater than or equals to, it would be great. Now look at the picture. It's shading 5, 6, 7, and 8, and then you can't even see the bars' heights afterward because they're so small. All right, so I'll just use this feature right here. You get 0.1146. So let me get rid of that. This will be equal to 0.1146. Now, that would be the same thing if you went to JUMP and did less than or equals to and put a 4 in there and got this 0.8854 and then subtracted that answer from 1. So this would be the same thing as saying 1, sorry about that, 1 minus that value was 0.8854. That would give you the same result. This 0.1146 number. All right, finally. What's the mean number of claims? All right, well, that's just a formula. The mean of the binomial distribution is found by taking n and p and multiplying them. N was 11. P in this question was 0.25. So we'll just run to our calculator. 11 times 0.25, which is 2.75. So that answers the question of, hey, on average, when we study these 11 people that are, in this policy, on average, how many can we expect to file a claim in the next policy period? That on average would be about 2.75. All right, so if you have any questions, be sure to email me. Thanks for watching.